Give me a shout out if you can hear me and you're watching, so I know who's on. Alright, this one unfortunately is going to be quite a bit of writing for definitions in the beginning, okay? The good news with this lesson is the only thing you really need to worry about is the definitions. As far as I had noticed on the test, and we'll go over that tomorrow, the study guide, the only thing I saw on there was definitions, and you just match the definitions, okay? We will go into problems that will help you with the homework, but like I said, the only thing you really should worry about is the definitions. Alright, so this is simple harmonic motion. And I'll try to not go too fast. It's really hard because I know I'm a fast writer and I can't see you guys, so if I'm going too fast, just let me know and I'll slow down, okay? Alright, so simple harmonic motion, you want to think of anything that has kind of like a wave that goes with it. So radio waves, even though you can't see them, that would be an example of simple harmonic motion. Other things that you can't see but would be in a wave format would be light waves. Also, your sound makes waves. Believe it or not, X-rays also have a wave type formation. But that's what we're talking about. And most of this stuff, you can't really see it. So that's what we're talking about when it says simple harmonic motion. The other motion that they're going to talk about is vibrational motion. So vibrational motion would be like a pendulum swinging. It would also be if you had one of those tuning forks and you hit it and then it makes that vibrational sound. That would also be another example. And then the one that's most commonly going to be in the on all of the homework assignments would be a weight bobbing on a coil. All right, and you're just going to see me pausing because I don't know how fast you guys are writing or if I need to slow down or speed up. It's hard to judge when I can't physically see you. All right, so here's going to be some examples that were on the study guide. I haven't looked at the actual test yet. I plan on doing that later today so that I can give you some more guidance on the study guide like we do in class. These were the ones that they focused on. So I'm going to star the ones that you should probably really know. So equilibrium position. And on the study guide, all it was it gave the list of definitions, and then it had an A, B, C, D choice for the words, and you just matched them. So equilibrium position, that is the rest position. The other one that you really need to know, and there's going to be several of these, of course, amplitude. So we've talked about amplitude on the graph where it's like the highest and the lowest point. So on here is the distance from the object's rest position to its point of greatest displacement. Okay, so make sure you're writing these definitions down. All right, then we have the period. So the period on here is the time required to complete one vibration or oscillation. Okay, and then we have frequency. And the book gives it like a really fancy F as the notation for frequency. But that's the number of oscillations per unit time. Okay, and then this has an equation, so frequency is equal to the W divided by 2 pi, where W is greater than 0. Okay, and these are basically the definitions that you're going to need on the test. Those were the ones that showed up on the study guide. Like I said, I'll look at the actual test later tonight so I can tell you tomorrow officially what you need to study for your test. Alright, so Simple Harmonic Motion has some formulas that we need to go over, and then we'll start some of these problems. Okay, so it says an object that moves on a coordinate axis so that the distance d from the rest position at times t is given by either, there's two equations you can use. So d equals a cos of the wt, or you could use d equals a sine of the wt. A has to be greater than 0 and W has to be greater than 0. And the amplitude is the absolute value of A. And the period is still 2 pi over W. Alright, so we're going to start number 6 in the assignments, which I think you have to do number 5 and number 7. So this should be close to your number 5, although this one's number 6. Alright, so it says an object's attached to a coiled spring. It's being pulled down a distance from its rest position and then released. Assuming that the motion is simple harmonic with period t, develop a model that relates the displacement d of the object from its rest position after t seconds. Also assume that the positive direction of the motion is up. Alright, so we have that A equals 10 and capital T is 3 seconds. So this is the one that's going to help you for number 5, even though I'm actually doing number 6. Alright, so for this one, if you want to avoid a phase shift, which of course we all do, you're going to want to use the cos formula. So we're using the cos formula so I don't have to worry about shifting anything. So we're going to start with the general formula. D equals A cos WT. And I know that W is a Greek letter. I'm just going to call it W. Alright, now if you go back to the amplitude is the absolute value of A. So this is a little bit tricky because it says that we're having a coiled and we're pulling it down. So we got our little coil here and the weight is going down. Okay, so since this is a downward placement of our weight on the coil, the absolute value is actually going to be -10. Okay, since we're going down, you need the negative to represent a negative direction. So your A is really going to look like -10 when you go to plug it in, okay? So far we have D equals -10 because the weight's pulling down. We want to talk about the down motion of the coil, not it going up. Cos WT. All right, now this capital T right here, that is the period. So if you remember, capital T is the definition we use for period, and that's 2 pi over W. Okay, they told us that T was 3, so we're going to plug 3 into our equation here. So now I have that 3 equals 2 pi over W, and I need to solve for W. So to solve for W, I need to get rid of W, so opposite of dividing would be timesing. So I'm going to times both sides by W. So now I'm left with 3W equals 2 pi. Again, we're solving for W. So we need to divide by 3. And our W is going to be 2 pi over 3. So now all I have to do is plug that into our formula, and then we're done. So D equals -10 cos 2 pi over 3t. And that's your answer. So it's really not as bad as it looks. You've probably never seen this before, but it's not terrible. All right, and then we're going to do number 10. And number 10 is really close to number 9 that they're requiring you to do. All right, I'm going to turn this page here. Okay, so this number 10 is the one we're actually doing, but when you're looking for your homework, this is going to help you on number 9. Okay, so number 10 says to rework number 6 under the same conditions, except that at time t equals 0, the object is at its resting position and moving down. Okay, so again, this A is still going to be the same as it was in the last problem. Your capital T, which is your period. So capital T is for period, not time. Your period is 3. Now they're telling you the time is 0. Okay, well, you actually did all of the hard work on the previous problem. So we already solved for W since they didn't change any of this stuff. W is still the same. So you can still say that W is 2 pi over 3. You can rewrite the work if you want to. But we did that work over here on the previous problem. So I'm just going to go ahead and copy down that W is 2 pi over 3. And that was seen from the previous problem. So the only thing you have to do different on this one is instead of using cos, you're going to use sine. So D equals, And our formula for sine was A sine WT. All right, and try not to think too much into this. So the only thing that is different from this answer versus the last one is instead of it being cos, now it's sine. Everything else is the same. So this is -10 sine 2 pi over 3t. And we don't do anything with that t equals 0. I mean, the only thing that that's telling us is we're going to use sine instead of cos. So this is your answer. So when you do number 9, try not to think too much. Just change the cos to sine and you'll be good. Okay, the next one we're going to do is number 14. And number 14 is like number 13. So this is the actual problem we're doing, and it should help you with number 13. Okay, so they give you your equation. They want you to describe the motion of the object. What's the maximum displacement from its resting position? What's the time required for one oscillation? What's the frequency? All right, and they give you the equation. D equals 4 sine of 2t. Okay, so we'll start with A. So A says, describe the motion of the object. And I believe on that whole section, which I don't think you have to do that many. It's 13 to 20 on here, but I think the only one you have to do is 13. They're all simple harmonic. Okay, so it asks what is the maximum displacement from its resting position. So that means they want the absolute value of A. And your A is 4, so the absolute value of 4 is 4. I guess I'll make these darker for absolute value. Okay, so that's all you got to do for B. Okay, question C. What is the time required for one oscillation? So for one oscillation, what they're saying is time is the period. So they're asking for the period. Okay, so your equation is 2 pi over the W. Well, your W is right there. So this is going to be 2 pi over 2, because remember, that's W right there. The two 2's are going to cancel, leaving you with just pi. Okay, and the last question, D, is what is the frequency? And there was that formula for frequency. So frequency is W divided by 2 pi. Okay, so basically it's the same thing as the period, it's just kind of flip-flopped. So this is going to be 2 divided by 2 pi. The two 2's are going to cancel, so this is 1 over pi. Okay, and these were all your answers. So this section's not terrible. Okay. Alright, the next one we have to do is number 21. So we will do 22. Alright, but before we do that, I think we're going to need a definition before we can get into number 22. Okay, so dampened motion. So there's a formula for a damping factor. So damped motion. So you could also read this in your book because it's in the book too. But it says the displacement D of an oscillating object from at-rest position, oh wow, there we go, from okay, and then they're going to give you an equation. Alright, I'm going to slow down here and make sure we all got that copied down. Alright, this equation's kind of crazy, so just bear with me here. Okay, so this is AE, and the E has an exponent. So the exponent is negative BT divided by 2M cos, alright, here we go, square root. Like I said, you might want to just, this is kind of nuts, W squared minus B squared divided by 4M squared, and then on the outside, I think that T is, let me look in the book, but I think the T is outside of the square root even. Yep. Okay, so I kind of made I went a little nuts with my square root sign, so I'm gonna drop that back a little bit. This T is outside of the square root. T. Okay. Alright, I'll give you a second to write that down. That is found on page 712. I'm just basically copying that yellow box on page 712. Okay, so B is the dampening factor. M is the mass of the object. Okay. All right, they're saying the absolute value of A is the displacement at time t equals 0. 2 pi over W is the period. All of that's still the same, so I'm not going to bother writing that down. I think the only new things is the dampening factor and the mass of the object. Okay? So I think that's only the new stuff right there. All right, we're going to do number 22. So that's the one that we're doing. This should help you with number 21 on the homework. Okay, so it says an object of mass m and grams attached to a coiled spring with a dampening factor B and grams per second is pulled down at a distance in centimeters from its rest position and then released. Assume that the positive direction of the motion is up and the period t in seconds under simple harmonic motion. All right, so question A says develop a model that releases the distance d of the object from its rest position at t seconds. B says graph the equation found in part A for 5 oscillations using a graphing utility. Okay, so we have M is 20, A is 15, B is 0.75, and capital T, which is the period, is 6. All right, now we're going to write down that crazy equation. I'm just going to recopy that equation up there. I'm going to leave out the d of t just to leave some space. Okay, negative bt divided by 2m cos square root w squared minus b squared divided by 4m squared. This was not on the test from what I remember. So you can breathe a sigh of relief. I think it's only on this homework assignment, and that's it. Okay, so the A is 15, but remember that coil is being pulled down. So A is going to be a negative. So this is going to be negative 15. E is going to stay E because E is the exponent. It's the letter E on the calculator. So that's just the constant. Okay, your B is 0.75, so that's going to be negative 0.75. Okay, we do not know T, so we're going to leave the T the same. T divided by 2, and then the M is 20. All right. And then we have that cos there. We got our square root thing here. Okay, now off to the side, we're going to find W over here. So remember our formula. I'm going to do this W here because right now you're probably thinking, well, what am I going to put in for W because it didn't say W equals. So for this W right here, this is what my brain's thinking, okay? So my brain is thinking that capital T equals 2 pi over W. And we're going to use that to solve for W. All right, so we're going to times both sides by W. So I get WT equals 2 pi. And then we're going to divide by T, because I do know capital T. So W equals 2 pi divided by T. Okay, we're going to take that information and use that for this W right here. So this is going to be 2 pi divided by 6 because capital T is 6. All right, 2 pi divided by 6, and we're going to square that. Okay, minus b squared is that, so 0.75 squared divided by 4, and m was 20 squared. Okay, all of that was under the square root, but this t, this little t is not, it just stays a t on the outside. It's kind of like our unknown x. We'll leave that in the calculator when we go to graph this thing, okay? Move this over so we can see everything here. All right, now what you're going to want to do is you're going to want to kind of reduce stuff so that, I mean, you could put this in a calculator like this, but it's really kind of messy. So let's get it simplified down a little bit. All right, so I know 2 times 20 is 40. So what I want to do is try to reduce negative 0.75. I'm going to divide that by 40. Okay, so I get this decimal instead. So that would be negative 0.01875 t. Okay, cos. All right, so 2 squared would be 4, and 6 squared would be 36. So we want to reduce 4 over 36. Okay, so that's going to be 1 over 9. Now when you square this, it's also pi squared. So that squared goes to all of these. It goes to the 2, it goes to the pi, and it goes to the 6. So I already reduced the 2 over 6, but that pi is still going to stay squared. Okay, so this is going to be pi squared divided by 9. Minus. All right, now let's figure out what 0.75 squared is. Okay, so that is 0.5625, and then we'll type in the bottom 4 times 20 squared, 1600. And then again, that t is off to the side. Okay, so as ugly as this answer is, this is the answer for A. It is not very pretty at all. All right, and then we got to graph this thing. So that's part B. I'm going to run real quick and grab my graphing calculator. It will just take me 2 seconds, and while I'm doing that, make sure you have that all written down. Alrighty. Okay, let's see what we got here. Alright, so part B says to graph this. You don't have a graphing calculator, I probably wouldn't sweat part B. I know that none of this is on the test. All of this is just on the homework, okay? So here we go. So we're going to go to y equals, clear all that stuff out. -15. Alright, here's your E button down. Mine's way down here in the blue. So I'm going to go second, and then that will give it to me. Alright, remember alpha y equals brings up your fraction button. Oh, I guess I don't need my fraction button though, don't I? Let me clear that out. Okay, -0.01875. I'm using the X button for that. Use the over button to get over. Cos square root. Looking for my pi button. Okay. Second, and then this button here is my pi button. Oh, let me delete that actually. Let me use my y equals button there. Alright. Okay, pi squared divided by 9 minus, remember alpha y equals gets you that fraction button really nice. 5625 over 1600. Okay, I'm going to make sure I'm outside of that square root button on the end, and then I'm going to put my X in there. Okay. Something tells me I'm probably not going to be in the right units. So I feel like I'm in degrees, and I feel like I'll probably have to be in radians for this. Pretty sure I need to be in radians. Oh no, it's thinking. Okay, here we go. Let's change that to radians and see if it'll graph it now. Okay, I can see some of it. There it goes. It's starting to come down. I can see I'm cutting some of it off, so I'm going to need to change my window here. Okay, so it says graph for 5 oscillations, okay? So I'm going to change my window here. I can see it's going really slow. Okay, so for the window, on the X min, I'm going to make that be 0. My X max, I'm going to make 30. My Y min is going to be -15 and +15 for my Y max. Okay. If you use those window settings, it should give you a good graph. I feel like that is the slowest graph I've ever seen drawn. Okay, so while the graphing calculator is drawing that, we're just going to draw a little sketch. The big thing that you should note is that the graph is larger here, and as it goes down, it's getting smaller and smaller and smaller. Okay, so 5 oscillations means 5 peaks. So 1, 2, 3, 4, 5 peaks is 5 oscillations. So when they say an oscillation, they mean count from peak to peak to peak to peak. All right, so here's our answer for B. So we're going to write down the windows, so when you go to do this on your own, you'll remember what we used. So -15 to 15, here was 30, and this is just a rough sketch. Okay, I tried. All right, so I've got 1, 2, 3, 4, 5 peaks. So 5 oscillations equals 5 peaks. Okay, and then we just have one more problem and then we're done. All right, so our last one is number 35, and that should help you with number 33. Okay, so number 35 says, use the method of adding coordinates to graph f of x equals x minus sine of x. So what we're going to do is we're going to basically do an XY chart, is essentially what we're doing. Okay, so we're going to start with x, and the equation they give you is f of x equals x minus sine x. So we're going to pick several values that we know. If you're thinking of the trig circle, it makes sense to pick this one, this value, and this value. Okay, so we're going to pick 0. This one up here would be pi over 2. This one over here would be pi. Then we're going to pick down here, which is 3 pi over 2. And then the last one, go back to full circle, would be 2 pi. All right, so the first one we're going to do is we're going to set this one for the first one. So whatever the first part is, that's going to be your first one. So y equals x. We're splitting this off into like 2 pieces. So this is piece 1. This is the second piece. Your second piece is y equals negative sine of x. And those 2 pieces together will form your last one, which is x minus sine x. That was the whole thing together. All right, so when y equals x, it's just going to be what these were up here. So when x is 0, y is 0. When x is pi over 2, y is pi over 2. So these are just going to repeat. So I'm just going to repeat those. Okay, so for the other ones, I probably would use your calculator. I would make sure it's in radians. Okay, so we're going to do negative sine, and then you're going to plug in 0. So that pops out 0. Then we're going to do pi over 2. Syntax error. Uh-oh. Maybe I need to use the divide here. Okay, you're going to have to use the divide. You can't use the ABC button apparently. Alright, that's negative 1. Go over here, make that be just pi. I get 0. 3 pi over 2. That gives me 1, and then a 2 pi. So I would just type these in the calculator. That gives you 0. Okay, so then what you're going to do is you're going to add these two columns together to get this one here. So you're adding going down. So we're going to add 0 plus 0 is 0. Then I'm going to need to add 1/2 pi over 2 minus 1 is basically what we're going to do. So we're going to add these going down. Alright, so if I had 1/2 and I minused 1, that would give me negative 1/2. So that'll be negative pi over 2. Add these going down. 0 plus pi is pi. Add those going down. So 3 pi over 2 plus 1. So I could think of 1 as being, in my head I'm thinking that's 2 over 2, okay? So 2 over 2. So 3 plus 2, that would be 5 pi over 2. And then 2 pi plus 0 gives me 2 pi. So now basically what I have is I have my coordinates, my points for the graph. Okay, so the first one's going to be 0, 0. Then I'm going to have pi over 2, negative pi over 2. Okay, then I got pi and pi for the last one here. Pi comma pi. Then I've got 3 pi over 2 and then 5 pi over 2. And then the last one is 2 pi comma 2 pi. Alright, and then all I'm going to have to do is graph this. Alright, so our first one, 0, 0. Then we're going to go ahead and put our things here. So this is pi over 2, pi, 3 pi over 2, 2 pi. Okay, then over here we'll get pi over 2, pi, 3 pi over 2, 2 pi. Alright, so our second dot is going to be pi over 2, negative pi over 2. Well, negative pi over 2 would be over here. So pi over 2, negative pi over 2. Then we have pi comma pi. 3 pi over 2, 5 pi over 2. Okay, so that would be up here. And then 2 pi, 2 pi. Okay, and then you just draw what you got here. All right, is there any questions on this? Are you guys still with me here? Let me check the chat here. So I'm planning on tomorrow going over the study guide, okay? And of course, if I was given this problem on the test, I guess you would have to do coordinates like this, but you know. Alright, so your test, as far as I know, we're going to have to probably wait and see, kind of. If we go back to school next week, we'll just do it in class. If we don't go back to school next week, then WVU has this app or other website that they're kind of using that's going to proctor it, and I haven't looked at it yet because there was a password and he didn't tell us what the password was. But basically it sounded like it was going to use your web camera and you would record yourself taking the test, and then it would flag you if it noticed that you were cheating or anything. So if you picked up your cell phone during the test, it would flag you for that, and then it would call you out as cheating. And if they called you and flagged you out for cheating, I'm assuming you would just get a 0 on the test. So I think the only thing that they'll allow you to use, he said, was a scientific calculator, which would be something like this. And then the other thing he said that you could use would just be blank paper. So we'll probably have to really talk about that more tomorrow. I was planning on meeting tomorrow at 12:30 again. So would that work for you guys again tomorrow at 12:30? We'll go over the study guide and everything that's on the test. And then I was thinking, like I said, we'll wait till later on in the week and see if we can't actually test in class, maybe Monday or Tuesday next week, assuming we get back to school next week. And then if we don't, then I was thinking, like I said, then we'll have to go through that app process. They have proctors or whatever that watch you while you're taking the test. So does all of this sound good? Okay, Cameron, good. I gotta get it out of you. So that was kind of my thoughts, was tomorrow we'll go over the study guide. Okay, good. I'm not sure if Lucas is still there or not, because it said there was only 2 people watching, so I'm thinking it might just be you 2 watching. I'm not sure if Lucas had to cut out after watching some of it. But that's what I'm thinking. I'm thinking tomorrow we'll go over the study guide, and I'll do like what I did in class and try to go over which ones to really focus on and bring in other questions also from there. Okay, so make sure that you have your study guides with you tomorrow when we go for tomorrow's live stream. We'll go again at 12:30, okay? All right. Well, you guys have a good day, and I will talk to you guys more tomorrow, and hopefully I'll have more insight onto how the online proctoring test is going to work. But it sounds like you'll just be able to do it at home, and we won't have to meet up for that. So that's also another good thing. So then the only problem we'll have is you guys doing your labs and trying to get the rest of those labs done. But we'll just kind of go day by day and figure this out as we can. So finish up all that homework, and maybe we'll set a deadline for, like, tentatively right now Monday or Tuesday next week is kind of what I'm thinking, because I kind of want to wait to see if we're going to come back to school or if we're not going to come back to school. So, and until I know what Governor Justice says, we really kind of just need to kind of wait and see for now. If we know we're not going back, then we know which route we have to take. If we know we're going back, then we'll just do everything in class. All right, so I will see you guys tomorrow on the live stream at 12:30 again, and you guys have a good day.